Welcome to the SCL podcast, filmed in the MD Acoustics anechoic chamber at their testing facility in beautiful Gilbert, Arizona. Today, we are joined by Chris Canfield, an aerospace mechanical engineer who has led major programs at Northrop Grumman, a global leader in defense and space technology. Chris's work bridges engineering and strategy, and in this episode, he shares insights on how ambitious innovations are built, scaled, and delivered.
Hey, Chris, thanks for coming on our podcast today. Talk to us a little bit about yourself. Where are you from? Kind of how did you get to where you're at?
Yeah, so I was born in California, raised in Phoenix. A product of the public school system. I went to school at the University in Arizona, and from there I kind of went on to work at Orbital ATK and then Northrop Grumman, so through a merger. So I came up in the launch vehicle space. So first role was kind of in the structural analysis and test of kind of flight hardware and support equipment. And that's kind of my early years.
That sounds awesome. That's a lot to kind of absorb. So real quick, U of A.
Yep.
You studied?
Mechanical engineering.
All right.
Yeah, so then...
did you always know you want to be a mechanical engineer?
No, so my family owns a small business here in the Valley, and I came up kind of in my dad's shop, just tinkering with his toys and bothering his guys. And I worked in there long enough to meet some engineers and figured I want to be one. And I just kind of chose mechanical engineering because I'm a bit more mechanically inclined. I think that I'm able to use tools, identify what fit, form, and function meant at an early age. And that's why I went to the U in Tucson. And then I kind of sat in on a lunch and learn there. And I had no idea about kind of aerospace really on my radar because as a mechanical engineer, you kind of is a broad spectrum. So I listened to their speech and they were here in Chandler, local, and it was just interesting. But I listened to it out and I connected with one of the recruiters and I just shot my shot with him, kind of sat in with an interview, and then I took a semester off to do an 8-month co-op there in Chandler in the launch vehicle space for the structural analysis group. And I must have done a decent job because after that, I got an early offer post-grad to come on full-time in the same group.
Talk to me really quick about like your first time you're looking at design, right? And you're like, were you overwhelmed or did you go into this thing like super confident? You're like, I know exactly what's going on. How was that kind of going through that?
Yeah, I think that the highlight answer is like, yeah. But the reality is I think everybody walks in with a bit of imposter syndrome. Like you're not smart enough to be in that situation with people where there's, people that have PhDs in statistics or they're aerodynamicists or they're dynamicists, right? And I came up in my dad's shop and I just was like, okay, well, I know I can work really hard. So I figured out really quickly that everything looks the same on the computer. So I just started going downstairs and talking to the shop floor techs and asking them, especially as I got a little bit more autonomy, because in the beginning, they're going to give you grunt work, right? Especially as an intern, you're going to do the things that the engineers don't want to do.
Yeah.
So I found through just trial and error that the way to get onto the cooler projects, like one of the projects that I got on early on was the NASA Tipping Point project, where that project was funded by NASA to see if we could damp different events along the vehicle, such as like stage separation, engine ignition, things like this. So they were full. So I was just bothering those guys, dropping in on the shop and talking to the techs like, oh, well, what are you making this subscale composite part for? They go, these guys again, right? And I'm like, okay. So then I went into them and I figured just talking to them, what do you need help with? Other than to design and the analysis, because the engineers want to do that, the testing.
Sure.
And it was like this batching test files as grunt work, like running scripts or writing scripts to batch a bunch of these load cases, because a lot of times you'll have this mission envelope they need to account for. And you can run that load case individually, but some of them as a function of boundary conditions are very computationally dense. So you can't really stay there for 12 hours if you have a family.
Sure.
So I was like, hey, I'll write you a batch file so you can run load cases 1 through 16 and then come in and then post-process it. Oh, and then if you need to post-process, maybe I can run something through VBA in Excel to plot this for you to make an informed decision. So then that's how I got into those cooler projects, by just kind of poking around, asking questions, sitting in with the technicians, asking whose project this was. And then from there, I just built a relationship through the technicians to develop my own game.
That's awesome.
I was gonna say, so it sounds like what you're saying is you kind of bet on yourself a little bit, where you kind of said, look, yes, I'm hired for this, but you took it upon yourself to go talk to these people, make a relationship with these people, and then integrate yourself into these people by saying, I can help you. Whether they kind of liked it or not, you kind of did.
Probably, yeah. In that space, I think that you can either get work given to you or you can go get the work.
Yeah.
So since my dad has a small business, I knew the difference.
It sounds like you learned to hustle.
Yeah, for sure. At an early age, because my parents were like, hey, if you want this thing, do something for it. So that's kind of where I've always been like, okay, well, let me just go figure out what to do instead of waiting for someone to tell me what to do.
And then you were helping on the automate, like you're saying, you're running batch, like different coding, and you were helping automate. Did people see the value in that because you were able to obviously offload some of the work, but also it's like they can come up and it's already been done, right?
Yeah, for sure. And it's definitely a mixed bag too, because people will get it and then initially it's going to be terrible.
Sure.
And so like that to be fair. But then I got the opportunity to sit with people and build relationships with people that were really smart, who turned into informal mentors that I could go to for analysis-based questions, coding-based questions, design-based questions, because I think I took that initiative to try to help the team. And at the first cut, it's probably terrible.
Sure.
And the truth is, even when I kind of mentored younger engineers and go through the space, I can do something way faster than they can. Well, it's only because of experience.
Yeah.
But if I teach them how to do it, now carve time out of my day to do it, then in the future, I'm betting that they're going to get good at it. I'm not going to need to touch it. And I think that's the mentality of the people that took an interest in me, was that, hey, he went to go just try this thing. It may not have been good, but let me go show him really quick, because in the future, this will be easier. This is how I like it done.
Yeah.
And this is the way we want it presented, because afterwards I have to take it upstairs and this is how they want it seen.
Interesting. So do you see, like, because this is the first time we had anybody on the podcast like working right in, I'd say, a larger, defense contracting. We've had NASA and folks like that, but like, now you're working on various components of launch vehicles, right? Like you're saying, is it the experience? I mean, your experience being a go-getter, you can communicate really well, right? You're telling us your story, and I love that. But sometimes I think of engineers maybe not being able to communicate as well. So does that exist? Number one, is that true? Like my assumptions, like some folks talk well and some folks, they struggle. And like, how do you break through those barriers? Like if they don't communicate as well?
At the highest level, that's where I look and aspire to, is I found people that had a growth mindset. So there was this VP that I really admired, and I'll keep his name private, but anybody that's close to the group will know who he is. And he got his start as an analyst, and he was just by reputation very hard to work with because he's brilliant. He's one of those guys that could have been an astronaut,
sure,
but he was colorblind.
Yeah.
So it's like, that was the limiter. But you could just listen to this guy and you could be like, hey, in engineering school, this guy did all the homework problems. Like he did them all. Like you could just tell.
Yeah.
Right?
Yeah.
And I remember talking to him, and when I met him, this was further in his journey, but the guys that I came up with, I always took an interest in both sides of the engineering group. So I love the graybeards and stuff. Like they're great. They had a lot to teach, like the hand calcs, the scripts and stuff they had done. So I would talk to them about how he was coming up, right? And they would just say he was very, very difficult to work with. The expectation was just so hard. It was that engineer-intern relationship where they're like, just get out of the way, I'll do it. Because he will.
Yeah.
He would. And he's a workhorse. But I remember when I met him that he would read books on management and communication. And we would talk about that. And he maybe didn't know this, but he had a huge kind of impression on me to where I just had my book list. So like books like Extreme Ownership by Jocko Willing, and these other types of books where you understand that if you want to rise to the highest level, you need to be able to, one, change your vocabulary depending on the audience, and then two, your delivery based on the deadline. Because if I'm really busy and you give me a page of text, I don't have time to read it. But if you know I'm really busy and you anticipate that and you can turn it into maybe a paragraph or less plus a table or a graph, you're my guy. I'm going to call you. So I think that I figured that out and I just enjoy it. I think that it's important to be well read. I think that being someone who is developing this theory, who I have not coined this and this is many others, but a skill stack where you can take a few things that on their own, they're not really valuable, but in combination, they're powerful. So the example that you mentioned, there's the engineer and he may be very good at analytical rigor, and on its own, that's valuable to a certain degree. But if you take that and then you layer on public speaking at a high level and interpersonal communication and being able to address, different situations, now that person becomes more valuable, both to the team and to the larger group.
I'm listening to you say this and I'm just thinking like you are such a great communicator, right? Like it just is blowing my mind because like you're it sounds like you can you can explain complex concepts in simplified manner, and you're saying like you value people's time, right? And people who you are around, they don't want to have a stacked report. Did you learn all this communication like you're saying, like some of these books, or was it through the job? Were you born with it? Is it a skill that can be learned? I mean, everything you're telling me is just phenomenal. It's awesome.
I appreciate that, but
I'm not just trying to rub you, like I'm not trying to like stroke your ego here, right? But like I'm just saying, right? I mean, I'm just saying like it's great. You're a great communicator.
No, it's true. With somebody who did schooling in predominantly public speaking, you are a very good communicator. I've gone to plenty of city council meetings, different things, just to explain a hard concept. That's engineering. We talked about that earlier. Engineers that aren't the easiest to talk with like that. So,
but I mean, is this a passion of yours, or how did this happen?
I think
I'm putting you on the spot.
Yeah. And it's one of those introspective moments, right? Where we sit with our thoughts and we're like, is this really unique to me? It
is unique. Trust me. Like I've already talked to you about, like off camera. We talked about like how you put out some LinkedIn posts that are super intriguing and like you got some traction and this and that, but like the concepts, the writing, the being able to pull from over here and pull it all together in an efficient way. Like there's a skill to that, right? And I call it the intangibles because and I this is for my wife, and she literally says, look, people can solve math and people can do this, but you know what the intangible is like how do you connect people to people, right? Like or how do you were talking about management, right? And you're talking about the books and you're talking about like how do you do this, and it's like I'm like sometimes like do you have it or you don't, or is this like learned or is it not? Some people are really great at math, some people struggle their whole life with math, right? So that's where I'm kind of going with this. It's like your ability to communicate, the way you put these thoughts down, the way it's just a great skill you have, right? So yeah, I'm telling you right now, like to your face you do, but like it's more of like I'm trying to understand, like could an engineer or is this learn this skill, or is it I don't know.
I was gonna say on the flip side of that, I'm kind of looking at you and your response to that was almost like I didn't realize.
You didn't realize you had it.
like I didn't. Maybe you didn't consciously sit down and be like, I want to read books to learn how to better communicate and how to talk to people and how to relate to people who maybe are the hard. Like you mentioned the VP who was hard to work with. Like I know for myself, years ago, I said the guy who's the hardest to work with, I want to be able to work with, and that was something I purposely worked for.
Yeah.
You may not have realized you were doing it by the response you kind of gave, where you like really introspectively looked at it. So
yeah, I think that it's definitely a combination of things. You may have to ask my parents to see that if I was.
You're born with it. Yeah, we gotta.
Guy,
was he a chat? Was he really? Yeah, that's funny.
Yeah. But the truth is,
you were a boss at a young age.
You were really running.
Baby,
I was say you were really running that business. They're just like, okay.
Yeah.
I was doing the accounting at an early age from my dad. No, so I think that skills are definitely learned.
Yeah.
Now, curiosity is the limiting factor in my opinion. So I definitely believe that I'm a curious person, and I like to read, like I mentioned before, I like to be well read. I think that it's important to understand different social dynamics, both professionally and in a personal setting, relationships, right? So for me, I think that practice is just interesting.
That's awesome.
So I strive to do that. I think that I'm a bit more hypercritical when it comes to produced products, both for my public and both professionally.
Sure.
So I like to really dial that in. But if you were just sitting and talking with me as we were friends, you would know that the books on my bookshelf represent a collection of ideas, including communication.
That's awesome. So kind of like going back to your work here. So project highlight, what's been kind of like, hey, this is the feather in my cap. What's that look like?
I think
do you have
that
too many?
Yeah, well, I wish, not this level of the game, but I think that there's definitely a few that come to mind. I think the last project that I was working on was very rewarding. So one of the last things that we do, well, not one of the last things that we do, but one of the last things that I did is we ran through a material characterization effort to qualify composite hardware. So to do that, there's a few different ways you can do this. You can kind of tap into a database, and you can kind of take material allowables and you take them. Or you can build upon heritage data. This would be data associated with your previous vehicles or your previous parts. And you could choose the same material system. But for this particular program, we wanted to diversify a bit because you want to be able to go to different suppliers. So supplier substantiation is important. And those nerds out there will know what I mean by that when people say they can do something, even if they can say they can do it on paper, it's very rare that you get that back to spec, even if it's to print, because things are hard. So you want to not get locked in by one distributor, because the truth is, especially in the launch vehicle space, as a function of the greater market, you are a rounding error in terms of your order size. So someone like Boeing produces much more composite material than a launch vehicle provider like SpaceX or Northrop Grumman will. So for those reasons, we wanted to have more performance capability and flexibility in the future. So we selected a different material, and we wanted to characterize that material. So I went through and authored the material characterization and development test program that would qualify that composite material through industry standards and get it ready for qual testing of the structure. So that was really interesting because that takes it all the way down from the coupon level. So you need those material properties that feed into the analysis, because your primary customer for that product, if you will, is the analyst, because they use these things in combination with things like knockdown factors to account for temperature variations. And in this particular vehicle, we were bounding the problem through different environmental conditions. So I had the opportunity to go out to a test house and kind of go through that because I authored the program. But also in combination with that, you want to do development testing because there's things that you can't capture. For instance, in a composite launch vehicle fairing, it is very hard to show good safety factors. So being able to design this type of part, get it ready for a subscale testing to kind of feed into the analysis group downstream was really interesting. So I think that that's a big one that stands out because it goes from the component level, produces the mechanical material properties that feed into the analysis. And through that effort, since you were that person, in this case for me, I led the hardware composite effort where I would get inputs from the group as we move through manufacturing of those parts, 2-3 interstage, shrouds, or fairings, they're interchangeable. And understanding how that works at a larger scale, I think that was really one that stands out as a story.
Does this help push towards different composites, I guess, like this? Does this help drive innovation on those things, on those components? Does that make sense what I'm saying?
Yeah.
Like if it doesn't make the list,
Yeah.
right, it can't get onto the aircraft or onto the spacecraft.
Yeah, that's a good question. I think at the root of the question is, how do we define the requirements?
There you go. Yeah.
So defining the requirements initially is a function of industry standards
Okay.
and requirements set by the customer and by the group.
Okay.
So it's this back and forth exchange. For this particular vehicle, it was a DoD-based customer. So
Got it.
defining the requirements needs to go through a few different avenues, especially in the launch vehicle space. Initially, you can use kind of open source material properties to pound your problem early on in the development stage before you make your way through material characterization, because it is a lengthy effort at long. So that's how you begin, and you can do a lot of things to bound the problem. You can find NASA docs, which we often do, European space agencies. You can kind of bound it this way. But the standard in the aerospace industry, and I believe it's for the aircrafts as well as launch vehicles, is you would follow the test required in the composite material handbook, so CMH 17. And it'll run through all of these standardized testing, ASTM standard testing that you need. And you basically filter down to the most important tests to bound the problem. Now, going to somewhere like a NIAR in Wichita, so shout out to NIAR, they're amazing. You can get help from their team who they make it their business to understand how to do this at the highest level.
Got it.
Now, you need to do your homework to go into a building like that and to do this level of testing, because it is very expensive to do, especially when you're going for like A or B basis, which is a statistical kind of bounding for the materials to understand. So that, I guess, is maybe the root of your question. How do we define the requirements? So we usually do it through standardized documents, NASA, European Space Agency, get what your hands are on, allowables if they're available, and similar to bound the problem, maybe you use some knockdown factor curves to account for the environment that you're in the development stage. And as you move through to, you qualifying the structure, you need to have those mechanical properties locked in.
Sure.
So that's after the fact, though. So initially you're basically just refining, and you're using heritage data, which is basically just a fancy way of saying data that you have in the company.
Sure.
Data that you have in the company to inform the models, and you're constantly going through this back and forth design, test, iterate, design, test, iterate, design, test, iterate. Now, the people doing it at this highest level, that would probably be someone like SpaceX, who's vertically integrated or rapid production. And you can see them if you just look at, like, say, something like the Raptor engine 1 versus Raptor engine 3.
Sure.
Now, they've taken that through the basic inputs and requirements, and they've moved it through just through testing and optimization to get to where they are.
And is that, well, so going back, I want to talk about SpaceX for a second, but like, this is obviously not things you're going to ever learn in school, right, in college. So coming out of college and then going into, like, actually getting into the workforce, it had to have been a huge learning curve.
Definitely.
Right?
A lot of on-the-job training.
So even the transfer of information, right, from like the senior staff going to the junior level staff or to the intern, it's a huge, like, what would you say for the first 5 years of your career, like getting up to that level? Is it a huge, like, you're just like soaking it up like a sponge, or how does that happen?
Initially, I think you are drinking from the fire hose, to be sure.
Sure.
And as you move through that and you gain responsibility, I believe you need to become more efficient as you move through, because as you progress in your career, more the responsibilities become many, but the time is the constraint.
Yeah.
So you can overwork yourself, or you can be more efficient at, hey, maybe on the weekend I'm going to learn how to write scripts to batch load cases. I'm going to learn how to plug into APIs into, the finite element tool to kind of hang out with my girlfriend this weekend.
Yeah.
So yeah, I think it's a combination of things.
Okay.
Yeah, I was kind of thinking about it because you were going through all these steps and talking about, everything that kind of goes into it. What's the kind of time frame that you're looking at when you do these testings? Like, is this a month thing? Is it a year thing? Like, is it, is it one of those things that you could potentially be working on for a good portion of your career, and then
it starts back over again for the
starts
next,
back over,
right? It's just like it's a cyclical, right, for the next program.
And I only say that because I look at like us as an acoustics company. I mean, I've had projects I've worked on for 2-3 years at a time, and then it ends, and suddenly I'm like, oh, everything I was doing day in and day out every week, like
it's done.
Suddenly done.
Yeah.
Now we got to change that thought process.
Yeah. So it's definitely a spectrum. So like the development level tests, those are things that we move through as a function of the mission, and you kind of inform the models back and forth. But something like the material characterization effort, likely you're not going to do it often. It's only when you're trying to qualify a new material. So that is going to be a much longer test. So something like a material characterization, I mean, you could probably condense that down, but that could be anywhere from say 6 to 12 month effort to do that level of testing, just because the amount of rigor and different tests that you need to capture is quite large. And then the inputs associated with that too are things that happen before that effort, writing specifications that feed into the material, these types of things. So the development test efforts, those should be quick. Those are a function of mission or need, and they kind of iterate back and forth, and we should move through those as we move along the mission or as we approach flight. And the material characterization, as we develop a vehicle, that's going to be a much longer effort, sometimes months or maybe even a year or more.
Okay.
So going back to SpaceX then, because like you just sit there and said, going from Raptor 1 to Raptor 3, right?
Yeah.
Like that growth, I mean, that's really impressive, right? But because they're going at a faster scale, and now as they're testing, right, super heavy or whatever, and they're seeing more failures, that just in your opinion, a good thing, bad thing, or it's just a thing?
In my opinion, so there's the biggest case study that you can compare Starship to, which is the biggest vehicle to date, is Saturn V. Because that comparison really shows how iteration cycles can change the entire development timeline. I'm not sure about the exact numbers, but it's clear that SpaceX's rapid test and iterative approach has dramatically accelerated how quickly they can develop and learn compared to legacy programs. Now, you can take a more traditional route, like Saturn V, where the goal was to get everything right before first flight, or you can follow the newer route, like Starship, where you learn by flying, iterate quickly, and achieve critical milestones in a more compressed time frame through that feedback loop. And that's what's interesting. That mindset shift. It's less about perfecting everything up front and more about learning through failure. Now, I'm biased. I am the latter person because I came up in my dad's shop and I know what it means to be a part of a sweaty startup. So I am for like test it, break it, use that to inform what you need to do, and let's learn what we can from each flight, and then let's move forward. Now, I understand that it's a business, and especially publicly traded companies are accountable to shareholders. But if you're a bit more ambitious, in my opinion, you are going to go much further, much faster down the road if you're willing to accept failure, because you can either work to get this thing perfect on the first flight, Saturn V, or you can move through and fail along the way and get to flight much faster, Starship.
Yeah.
So what you're saying is failure can actually be a good thing. It can help that progression a lot faster. I say that because people out there hate to fail, right? I hate to fail. It took me years.
They hate to admit to fail.
It took me years to realize that those failures are really some of your biggest areas of growth, right? And it sounds like even from a mechanical standpoint, they can be a very big opportunity for growth, even though they hurt at the time and probably hurt financially at the time.
I mean, it hurt everything. I think there's lots of programs out there that fail, and then that people's livelihoods are gone. Right?
Absolutely. That's the double-sided sword.
That's the double-sided sword to all this, right? It's like, yeah, you can have a mission fail, and you don't have loss of life, great. But it's still loss of economies, loss of people's livelihoods. I mean, there's a lot of other things. What's your journey now? Like, where are we at? What are we doing? What's if you want to dive into that?
Yeah, I think just looking for my next thing, I kind of use public platforms like LinkedIn to share my ideas, to identify companies that I think are interesting, that I can kind of move into my next role or even my own gig. So I'm a big believer in buying down risk. I think I'm a risk-adverse person. So I think as I share ideas, I connect with others, as the signal becomes large, that's kind of the way I move. And being very selective about the next corporate role that I take is important for me in this chapter of my life. So I'm kind of filtering those two things as I balance the next step.
Okay, that's awesome. Do you have like any advice for like the younger generation coming up that you would want to impart on them, that would sit there and say, hey, yeah, you know, coming out of college, expect this, but really, you know, what would be some of that advice?
First and foremost, I think, because I see this amongst my family members, is the biggest thing is like nobody is thinking about you as much as you think they are. So do the thing that you want to do.
I love that.
I
Yes,
absolutely.
I love that.
Yeah. So and I think that it's just a product of getting older, and maybe I believe this, but nobody's thinking about you as much as you think they are. So do the thing that you want to do. Take the risk. Take the year off. Take the time to collect. Go travel around the world. Be well-read. Be not scared to go into situations where you think that you are not qualified to be in. Push your way into that room. And as you do, you increase your surface area of luck for things to happen.
Surface area of luck. I love that.
So I think that the formal path is very appealing because it's well lit. You go to school, you get the corporate job, you get the fancy job, you go to the Fortune 500 company. But paradoxically, that's where all the competition is, because it's well lit and it's safe and it's well defined. Now, I think more opportunity lies on the outskirts of those. Now, they may be tangent to where, say, you share your ideas or you connect with big corporate companies, but and this is a very, especially in coming from an engineering background, like sales, like it makes you ick. But truth is everything is selling.
Sure.
Don't be scared to try to land a consulting job. Go call a prospect. Find a side hustle to kind of diversify yourself, to build some agency.
Okay.
Because I think these things are important. So I think that would be kind of the meta level advice. Now, the professional level advice would be, if you can, work in a lab. I think that that's a really great job. In college, you can, a lot of times you can do it for free, right? You can find the professor that's doing the cool thing, go there until you can find him or help him or them to get a grant to get you paid. But initially, just do the work. Learn what it means to set up an accelerometer. Learn what it means to run an Instron. These small efforts on your resume displayed are going to get you that first internship or job at that big company.
Sure.
Especially if you're coming from a public school system and you haven't gone to a fancy school. So, but I think that that's a mixed bag too. So I think that is the biggest thing, especially as you're in school. Go to those opportunities to put yourself in the room, to know how to understand the equipment, to meet those people, drop in on those lunch and learns when you hear about companies that are coming to your campus, even if it's outside something that you thought you'd be doing, you know, aerospace engineer versus mechanical engineer. Just go there, drop in on them, ask questions, be curious, be bold. I think walk to people, ask them questions, talk to them. I think these things have done me well or done me a service. And I think that they are the less talked about skill sets as I move through.
That's awesome.
I think it's. As you were talking, I was like, "Man, where were you when I was 25?" Like,
Seriously, that's the point of this whole podcast.
That's what I needed. I needed to hear that, and it wasn't until later in life that I realized that those uncomfortable times, that, like you said, you know, you take that well lit path, but if you take the not so well lit path, that can be uncomfortable, but it's some of the best growth. It's some of the best opportunities. It's some of the best things. I mean, that's partially why I'm here where I'm at, because I took that not so lit path, and it's just I hope anybody who's younger listens to that, because you know, betting on yourself and doing it is really the best way, I think.
We really appreciate your time. Honestly, you coming down here, spending an hour with us, and just listening to you, it's been inspiring for me. Is there anything else you would want to say before you go, like that you didn't get to say, that would be interesting? And no pressure. If there's not, no big deal. But I'm just, you got some. He says some good things on right, on your LinkedIn, and I'm plugging that a little bit for you because it's like, you know what, I think it's great, right?
Yeah.
Like that's how we connected, just FYI. So, but is there anything else that you'd want to say that would be, you know?
Yeah, no, first,
Interesting.
I appreciate it. Thanks for having me out. The lab is really awesome. I mean, look at the setting that we get to do the podcast in. So this is like the coolest area that I've been in a long time. So I think it's really awesome. You know, and speaking directly to how we got connected, I think maybe it's that. Maybe it's, you know, shoot your shot. Drop a DM to that person that you wanted to connect with. Try to add value to them before you give an ask. I think that I'm really big on that. That every communication exchange I try to do, I try to provide some level of value, especially if people that are further along the path than me, and doing it with a sense of not giving to get, because I think that's transactional, and I think that we want to invest in relationships based on, you know, wanting to add value to one another as an exchange. It shouldn't be draining to be connected with someone. And if it is, I think that that's a signal that you need to disconnect from that person. So I think that maybe it's, you know, provide value to other people, reach out. That would probably be the first thing that comes to mind. Because I think especially as I see engineering students reach out to me, the theme that I hear is, you know, how do I get started?
Yeah.
And following my highlight reel, truth is it's not going to get you there, because I had a ton of missteps along the way that didn't make it onto my CV. But I'll tell you that those are the things that got me into the room that is the experience that's on my CV or the experience that's on my resume. So maybe go out and connect with people, meet people in the real world. Don't be scared to drop them a DM and connect with them. And you really just never know where it'll go.
I know. I'm excited for the future, just because honestly, like when you put it like that and you talk about like LinkedIn, there's some powerful, you know, I just like that it's not the place where, you know, it's like, hey, TikTok and this, that, like it's a technical place. It's like a marketplace. It's a place where you can do some great connections, and then don't be afraid to fail. Like you're saying, don't be afraid to do any of that, which is just great. Well, we appreciate your time.
Yeah, that
And
was killer. Thank you guys for having me. This was awesome.
Thank you.
Yeah.